On calculating specific charge. Okay, specific charge is defined as the charge to mass ratio with units coulombs per kilogram. Okay, now all you have to master is the three different ways that you can be asked. Three different ways. So there are three different possibilities. And you just have to be careful and you have to decide what you're being asked. So the first one is the specific charge of a particle. And this is the easiest of the three. And in fact, it gives you the specific charge of an electron in the data booklet. So they're not going to ask you that. And all you have to do is the charge of that particular particle. So if it's the charge of a proton, specific charge of a proton will just be the charge, which is 1.6 times 10 to the negative 19 coulombs, divided by the mass of a proton, which is 1.67 times 10 to the negative 27. So that's pretty straightforward, and that would just be for any particle. You just take its charge and then divide it by its mass, and that gives you the answer. Now, slightly more tricky is when you're asked for a nucleus. Now, I'm going to take, take carbon 12 as an example. So we see that these two numbers here represents the relative mass. So that means it has 12 nucleons in there. That means a mixture of protons and neutrons which add to 12. This one here, this gives you the proton number. And then by subtracting 12 from 6, you could see that that gives you the neutron number as well. So in this thing here, this particular isotope of carbon 12 has 6 protons and 6 neutrons. So I'm going to do the charge to mass ratio of this nucleus. So the charge is going to be the proton number because we're only interested in the nucleus. We're not interested in the electrons that surround the nucleus. So it's just the charge, which is going to be the proton number, which is 6 times the charge of a proton, which is 1.6 times 10 to the negative 19. And that's divided by the total mass of the nucleus, which is 12 times 1.67 times 10 to the negative 27. And that gives you your answer. Now, sometimes they'll say a certain isotope has this specific charge. So it may give you the value of specific charge. And it will tell you that it's an isotope of a certain, so let's say it's an isotope of carbon again. So then you know that an isotope is always going to have the same number of protons. So this is always going to be the same value on the top. And then it just might be, you have to work out what the nucleon number is. So then you've got this value of specific charge. So then that would be 6 times 1.6 times 10 to the negative 19 divided by the value that they've given you for the specific charge times 1.67 times 10 to the negative 27, and that gives you the N. So that would give you the nucleon number, and all you do is do the nucleon number minus the proton number, gives you the number of neutrons in that isotope. So that would be, so an example of that would be, it'd give you the specific charge of, and let's say it's an isotope of, let's say you got an answer of N is equal to 15, mass number is 50, or nucleon number is 15, so 15 minus 6, because you know that carbon 6, the nucleon number is 15, then you know that that's going to have 9 neutrons. Now the next one is slightly trickier for ion. So an ion is an atom that has gained or lost electrons. So if it's singly ionized, that means it's lost an electron. It would have an overall charge. The atom would have an overall charge, if it's lost an electron, of negative 1.6 times 10 to the negative 19. If it was doubly ionized, it would have minus 3.2 times 10 to the negative 19. So all you're doing here is working out the net charge. So you don't have to worry about the charge inside the nucleus. It's just by losing 1 or 2 electrons, or even gaining 1 or 2 electrons. So this should be positive. This would then gain. So if I take, let's take an isotope, let's take carbon, I don't know, let's call it carbon 14. So then carbon, which is 6, and 14, like that. So if I do my charge to mass ratio of that, will be the charge above. So let's say it's doubly ionized, so this one here. So it'll be 3.2 times 10 to the negative 19 divided by the total mass. So take that number there, 14. Remember, it's not just the nucleus this time. 14 times 1.67 times 10 to the negative 27. But this time you have to take the electrons into account because they're in the atom as well. So we also have to add how many electrons. Well, we've lost 2. So we look at this number here. So it would have 6 protons and 6 electrons if it was neutral. If it's been ionized, it's lost 2 electrons. So now it only has 4. So it will be plus 4 times the mass of an electron. And that would give you your answer. Now, this value here actually doesn't change the value if you just missed them out. However, if you miss them out in an exam question, you won't get the mark. So you have to either include them or just say after your calculation the mass of the electrons are negligible. But I would say just include them, then you're done.